Can you see the stream has started? Good afternoon, ladies and gentlemen. My name is Robbie Goswami, and it is my pleasure to be your host for today's webinar, The Effects of El Niño and Saharan Dust on Trinidad and Tobago. A warm welcome to all attendees and to our distinguished presenter. REACT is the Radio Emergency Associated Communications Teams, a voluntary non-profit organization that provides assistance in times of emergencies and disasters, working closely with first responder organizations and partners. Headquartered in Glendale, California, REACT started in 1962, with operations commencing in Trinidad and Tobago in 1964. The organization has therefore been providing service to communities for well over 60 years. REACT operates on the basis of charter teams. There are 10 such teams serving Trinidad and Tobago, as well as an umbrella body, the REACT Trinidad and Tobago Council. Members give up their time and assist with public service projects, including cultural, sporting, and other activities in which communications and logistics are critical. Radio communication technology is the mainstay of the organization's operations. Continual preparation via training, exercises, drills, and projects is key to the organization's preparedness activities. REACT works closely with several stakeholders, and it is through these partnerships that we host sessions like today. In 2021, we addressed the topic of the role of radio communications in disaster prevention and preparedness. In 2022, we discussed women in emergency communications and disaster risk reduction. In 2023, the chosen topic was the role of weather in being disaster ready. In 2024, we addressed innovations in volunteer technologies for disaster resilience. And in 2025, the topic was weather systems and their impacts on Trinidad and Tobago. REACT is pleased once again for the 6th consecutive year to partner with key stakeholders in hosting today's webinar. REACT has had a long working relationship with the Trinidad and Tobago Meteorological Service, or TTMS, and through the efforts of Corporate Communications Officer Camille Hall Graham, we are here today. Additionally, we acknowledge the Office of Disaster Preparedness and Management under the auspices of the Ministry of Homeland Security through Operations Manager Dennis Marcel and Deputy CEO Captain Retired Stefan Afonso, the Tobago Emergency Management Agency, or TEMA, through Director Alan Stewart, as well as Bert Williams, Technical Director, and Charmaine Williams, General Manager of HeartlightTV, the streaming provider for today. This afternoon, we have a qualified and experienced subject matter expert who has put together an extensive presentation to take us through and explore the topic, the effects of El Niño and Saharan dust on Trinidad and Tobago. We will have a look at El Niño-Southern Oscillation, or ENSO, and drought conditions, the Saharan air layer, the 2026 hurricane season forecast, as well as related meteorological hazards faced by Trinidad and Tobago. Webinar attendees can send in questions via SMS, text, or WhatsApp to the number 1-868-74-REACT. That is 747-3228 at any time starting now. We will also monitor the YouTube chat to discern any questions. Should we encounter any major technical difficulties or other issues that affect the program, we will attempt to recover. However, if we are unable to do so within 5 minutes, we will seek to reschedule. Please note that we will be proceeding quite informally throughout the afternoon, so sit back and relax as we hear from our distinguished presenter. Mr. Gary Benjamin started in the field of meteorology with the Trinidad and Tobago Meteorological Service in 1981. First as a weather observer and eventually as a meteorologist, an aeronautical meteorologist, a synoptic analyst, and a weather forecaster. He has had considerable experience in analyzing and predicting the state of the atmosphere in WMO's Region 4. He is also a trained basic climatology and climatology and agrometeorology. Gary has done several FEMA courses in emergency management, for example, NIMS, ICS, emergency planning, etc. He is trained in CERT and is a licensed amateur radio operator. He possesses a technician diploma in telecommunication systems and a BSc Information Technology from UWI. Gary is a member of the Radio Emergency Associated Communications Team's REACT. He is presently employed with the Trinidad and Tobago Meteorological Service as a meteorologist based mostly in the communications department and also performs duties at the synoptic branch. So, without further ado, it is over to you, Mr. Benjamin, for your presentation.
Thank you, Robbie, for that introduction. It's always a pleasure for me to be here to expound on matters of the weather, and therefore I will always take the opportunity to be on forums such as these to tell at least some of what I know. So we have a lot of information to get through today, and each one of the points could take a talk by itself. So I will require that you listen carefully, and any questions you may have, of course, you send them through the open channels available, and therefore we could try to see if we could answer as much as possible. So let me just get on to the first slide. Today, as Robbie has said, is basically meteorological hazards and impacts with the El Niño and the Saharan dust impacts also. In meteorology, we have scales, things operate in scales in the atmosphere. There's the global scale or the mega scale. There's the synoptic scale in meteorology, which is a very large scale, like areas like Region 4. And there is also mesoscale or the middle scale and micro scale. And the reason why I mention these scales is that the meteorologists now would have to respond in different timings and have different lead times to respond and give forecasts or predictions on what is likely to happen. So El Niño is one of those global scale systems, and we could predict it in a great time ahead. But as far as the micro scale, like individual thunderstorms, it could happen very suddenly with us. So we have to be operating within different scales as far as time and space is concerned. And the main weather systems experienced in Trinidad and Tobago are the sudden intense development of individual thunderstorms. We see them over the western areas. Some people call it West Coast convergence. I wrote a paper called the Polari effect. That is the name I give to it. And you can find it in the Parisian Guide 2025 on page 24. There's also the ITCZ. You know the ITCZ and its associated weather. In fact, today we have a yellow level out because of that same ITCZ. We have low-level and mid-level troughs and perturbations. From above because of varying speed and convergences of the wind, we have the African easterly waves or tropical waves, tropical cyclones such as depression, tropical storms, hurricanes, and potential tropical cyclones. We have rough seas, strong winds, Sahara dust events, and also strong insolation and heat spells. So these are some of the systems, and the impacts are usually from thunderstorms, strong downdrafts, gusts, lightning discharge, powerful, frightening thunderclaps, even frightening to people and disturb people and animals. There could also be wind and fire damage to many structures. Many times the thunderstorms, though relatively small, we could have funnel clouds and tornadoes and water spouts developing. We also have damages due to indirect or direct effects of cyclones, tropical waves, and the ITCZ, such as flooding, of course, and the winds. We would, of course, have loss of habitats and property, loss of livestock and pets, loss of productivity, and possible loss of lives. The floodings are street flooding, flash flooding, riverine flooding, and coastal flooding. Together with that comes landslips or landslides, not only in elevated areas, but also near the coastal areas, so we can lose some beachfront also. There are long period swells and choppy waves, which makes the sea conditions hazardous in open water and on the beachfront for both mariners and beach users. But the dust, we have increases in respiratory ailments and from Saharan dust, smoke, bushfires, and landfill fires. And of course, we have heat strokes, heat stress and heat strokes, which could occur. So those are some of the impacts we usually encounter in Trinidad and Tobago and parts of the Caribbean. Weather systems could result in events of similar intensities of impacts, even though there are different types of systems. And also within the same type of system, for instance, a tropical wave or the ITCZ, we would have very varying intensities of impact. So you may hear a tropical wave, and in some parts you may get sunshine, and some parts you may get devastating or strong thunderstorm activity. So there's a lot of variation in our type of weather. But let me first start with that global phenomena we call the El Niño-Southern Oscillation, or ENSO. ENSO is an oscillation between cold and warm and neutral temperatures within the equatorial Pacific Ocean. El Niño is the warm phase and La Niña is the cold phase. And that is basically what it is. Warm waters in the Pacific for El Niño, cooler waters for La Niña. And because of that, in the El Niño criteria, it must be found to be at least 0.5 degrees warmer than average over the equatorial Pacific. And that is because weaker than usual because of weaker than usual easterly trade winds. And the opposite is for La Niña, which is at least 0.5 degrees cooler than average and stronger than usual trade winds. Neutral conditions, of course, we see in the circulations that are set up within the vertical trade winds, vertical wind systems. We see in the neutral conditions, there will be much more rise in air over Indonesia or the Western Pacific and over the Caribbean area and southern parts of North America and Central America. We see also rise in air. So within the neutral conditions, we expect normal, just to use the term, normal types of weather conditions and over the western coast of Central America, Central and South America. We see a sinking pattern in the air. La Niña conditions, if you look at neutral, La Niña is just basically a stronger phase to neutral conditions where the rise in effects, currents would be stronger over both us and the Western Pacific, over the Indonesia area. But with El Nino, which we are concerned with these days, we are in El Nino. We see more rising because of the warmer water over the central equatorial Pacific. We see a greater strength of convective activity, and over our area in Trinidad and Tobago and the Caribbean, we see sinking air. And this sinking air would be a tampering down for the development of convective activity. Also, we see the air moving in the screen there, you'll see the air moving from left to right, and which is set up wind shears over us, and therefore could blow off the tubs of cyclone formations. So therefore, it could cause different types of convective activity to be tamped down, and it could reduce the amount of development of cyclones. So that is what El Nino basically do. We are talking this year, in this time, about the strength of the El Nino. A weak El Nino is usually 0.5 to 0.9 degrees warmer than normal. A moderate El Nino is 0.1 to 1.4 warmer than normal. We call a strong El Nino between 1.5 to 2 degrees greater than or warmer than normal. And a strong or super El Nino would be 2 degrees and above greater than normal. The effects of these in our air, in different areas, it tends, in the El Nino conditions, it tends to release a massive amounts of heat that was in the ocean into the atmosphere, and therefore it dramatically alters the world weather and the global heat. So we'll find temperatures rising across the globe, especially in the strong El Nino years. We have changes in rainfall patterns, and they may trigger heavy rains and flooding in some areas, while causing severe droughts and wildfires in others. Our area, we are affected by having less rainfall on average. So it also reduces the hurricane development over the Atlantic. And the number of hurricanes would usually be decreased. Local weather shifts, like southern United States, we see wetter and rainier winters, while in northern states, because of the warming, stay warmer and drier. But there's also positive effects of the El Nino. Because of the decreased Atlantic hurricanes, we tend to be less, we have less affected by hurricanes. And, if we're affected by any one storm, it could be very devastating for us. So any ease up we have in that development would be good for us. So the decreased Atlantic hurricanes could be looked at as a positive effect. We have milder winters, positive because it means then the persons in the northern regions of the United States and Canada would not be as cold and would not have to use as much heat for the winter. And so the heating costs would drastically be reduced. And in arid, dry regions where the El Nino causes more rainfall, of course, it brings heavier rainfall to those areas, and therefore much needed moisture and rain to help replenish reservoirs. So we could look at those as positive impacts also. And this is a kind of simulation 150 years ago to what is happening now. Of course, we didn't have the technology 150 years ago. So it's a similar simulation to show the similarities between the strength of the El Nino then and the strength of the El Nino now, which people are terming as super El Nino. So that is it for the El Nino phenomena. We could move on to the Saharan dust and the Saharan air layer and some of its impacts. The Saharan dust is basically and simply the sand on the ground of the Sahara that has been launched into the atmosphere by different mechanisms, and therefore it becomes an aerosol in the atmosphere, and it blows across to our area, across the Atlantic from east to west. What are aerosols? They are basically suspension of fine solid particles or liquid droplets within a gas such as air. So the aerosol Saharan dust is really these fine dust particles of different sizes that comes across to us. And they influence our climate by absorbing or reflecting the sunlight, causing cooling or warming effects by either aiding or hindering cloud formation. Also, it would affect the breeding of human beings and animals in different parts of the Atlantic and the Caribbean, according to how intense it is. There are surface wind phenomena which launch the dust into the air. So as the sun begins its apparent migration into the northern hemisphere, everything sort of wakes up in the northern hemisphere that was dormant. So we start to see different types of low pressure areas, surface troughs, dust storms, and sandstorms. And these disturbances from the surface would launch the dust into the atmosphere. And we have vast dust storms and sandstorms, some of which can extend as high as 6,000 meters or about 20,000 feet to the atmosphere. And we have a picture here, a visual picture with modern textual technology, picking up the extent of the sand in the atmosphere as it blows off the western coast of Africa, as it blows off the Sahara. You could actually see the dust and the thickness of it in this picture, and going a long way into the Atlantic. Now, we look at some simulation, some modeling here that we could look at and see the extent of the dust as it approaches the Caribbean and Trinidad and Tobago. Where you see in the red areas is the heavier dust, and the dust in the brownish is more lighter, moderate dust, and this is significant or high dust concentrations. Another picture here is in Trinidad and most of the lesser Antilles, Eastern Caribbean, enveloped in, I would say, moderate to at times significant or high dust concentrations. So we could look at it through the models and see what exactly is happening and what is projected as far as the dust is concerned. Now, after that, as the dust has been launched into the atmosphere, the Saharan air layer, it is in fact a hot and dust-laden air layer across the Atlantic, typically between 5,000 and 15,000 feet above sea level. And it is initially pushed by what is called the African easterly jet. As it is lifted into the air, the African easterly jet pushes it westward across the Atlantic, and then it picks up and encounters varying wind maxima and of varying strengths across the Atlantic. And it is estimated annually, and that is an estimation, about between 60 to 200 million tons of dust particles carried from the Saharan dust region of North Africa, where it originates and moving westward. So that's a lot of dust that comes across us every year. And this is showing how the African easterly jet is set up, and we'll see that later as far as when we talk about tropical waves. But it is because of the high pressure, the higher temperatures in the north over the Sahara, the cooler, more lush green areas just south of the Sahara. And because of that temperature contrast, we have the setup of the African easterly jet, which would take the dust that is launched into the atmosphere, pushes it westward across the Atlantic towards our areas. The pattern of the dust recorded reflects a pattern correlating with the sun's apparent south to north or north to south annual migration. So we see this pattern because all the energetics come from the sun. So whenever the sun is overhead in any part of the northern hemisphere, we see things starting to increase, become stronger, or to ramp up, if you like that too. Some effects and impacts. The Saharan dust here significantly affects air quality in Trinidad and Tobago and the region, leading to increased pollution levels, health impacts of respiratory and cardiovascular issues, as well as eye infections. Environmental effects include the absorption of both long-wave and short-wave radiation, contributing to localized heating by warming the dust-laden atmosphere. Some effects and impacts, again, are the visibility reduction. Heavy bouts usually reduce visibility to less than 5 kilometers. Well, I have seen it even less than that, more than 3 kilometers, some years at times. And this would curtail visual flight rules in an aerodrome, where the operating aerodrome operated minima is 5 kilometers. For VFR flights to operate, the visibility must be 5 kilometers or more. So whenever the dust begins to reduce the visibilities, tend to see it curtailing the operation of visual flights. The dust film also on the surface of the roads would reduce friction, and you have less stopping or braking ability for cars. And interesting to note, or important to note, is that with very light precipitation, which mixes with this dust, it becomes grease-like, and you could very well skid off without much push or impetus. You could very well skid off the road at any time. So when you see the Saharan dust, even driving on the road becomes hazardous. Those with respiratory ailments, the very young age persons, are most likely to be adversely affected. And it could also produce some harmful effects in the normally healthy when this dust is significant enough. So you are advised to see the Ministry of Health advisories and also to follow the advice of your medical practitioners, because those are the experts in dealing with the effects of the Saharan dust. So one important positive note, the Saharan dust deposits, it deposits nutrients to the Amazon and other forested areas. So despite all the negatives with the Saharan dust, it plays a crucial role in fertilizing the Amazon rainforest. It is rich in phosphorus, and while the Amazon soils would lose about 90% of their nutrients to rainfall and it washes out to sea, the Saharan dust provides a vital external source. Without this continuous input, the biodiversity of the Amazon would be adversely affected. And we have a picture here showing the contrast and the connection between the Sahara, the dust Sahara, and because of that dust coming across, it keeps the Amazon rainforest very lush and green because of this, the phosphorus-laden Saharan dust. We could just run through the heat season peaks, and Robbie, you could ask any question you like if we need to take a break and ask a question. But we have what the heat season peaks, and it reflects the sun's apparent migration over the northern hemisphere. The first peak on the northward pass over Trinidad, we've seen it here with the peaking mainly in May for both Trinidad and Tobago, and also on the southward pass around September as the sun progresses. And this is mostly all within our rainy season. Some people think because it's a rainy season, it will be cooler. No, that is the time when we have the most heat and the highest heating and humidity. And therefore, we get those peaks as the concentrated sunlight crosses Trinidad and Tobago on its way northward and down and southward. And all the attendant impacts of heat stress, heat strokes of people, animals, and vegetation. And therefore, at that time, we must also see how we aerate ourselves, how we dress, and how we hydrate, because it does have an impact, especially on children and elderly. And also, we have to look at the pets and the livestock. Robin?
Okay, so excellent indeed. I mean, that's quite a lot of information to digest. Gary has taken us through El Nino, the Saharan dust, and the heat conditions as a result. So just reminding all participants, you can pose your questions either via the YouTube chat, or you can send a text message to 74REACT. That is 747-3228. Again, 747-3228. That's the number that you can text, SMS text, or send a WhatsApp question. So 3 ways to ask your questions: via the YouTube chat, via an SMS text to that number, or a WhatsApp to the number. Again, the number is 74REACT or 747-3228. Okay, so Gary, first question we have for you, and you would have touched on it, so we want to ask you, can you walk us through how El Nino events typically alter rainfall, temperature, and storm patterns in Trinidad and Tobago, are there notable differences between moderate and strong El Nino episodes that we have experienced in recent years?
Yes, the answer is yes. The short answer is yes. There are noticeable differences because everything ripples outward. When the El Nino, the strong heating of the El Nino ripples outward and affects different parts of the globe in different ways. As I have said, where there is likely to be more rainfall, it might dry up the rainfall, and where there's likely to be colder temperatures, the temperatures could become warmer because this massive amount of heat emanating from the largest ocean, the Pacific, is almost half the face of the earth. And it doesn't have a great impact. So the stronger the El Nino, the stronger these impacts are. So we see, especially let's talk about the Caribbean and Trinidad and Tobago. What it does is if it tamps down or hinders the development of convective activity, it means then in a time like now, where the sun is high in the sky, so to speak, it means then there would be clear skies, nothing to really block out the incoming solar radiation, and therefore the re-radiation, the insulation to us would be even greater as the earth absorbs that more amount of radiation. When we have clouds, the clouds would block out the rainfall, the sunshine. So the less clouds we have, because the less tropical cyclones, then we would have more concentrated temperatures to deal with us. And one thing, as we talk about the heat transfers, cyclones are what transfers heat from the equator towards the pole. You will see them always trying to go around the high pressure cell to head northward, because all the heat that is gathered around the equator, the cyclones, are one of the major heat transfers. So with less cyclonic activity, of course, there will be a certain there will be a certain amount of gathering of heat or less loss of heat to the equatorial regions. So it would in fact raise the temperature, and of course, the stronger the El Nino, the stronger the effects for us. Robbie, I think you might mute it.
Yes, excellent indeed. Gary, thanks for that answer. And we move on either via the YouTube chat or via the number 74REACT. You can send a text message, an SMS text, or you can WhatsApp 747-3228. So I think we're having a kind of a masterclass here with you, Gary, in terms of breaking down for us that we can understand what I would imagine will be highly technical meteorological phenomena. So the next question we have relates to, you spoke about Saharan dust. So Saharan dust outbreaks have become more frequent and intense. At least that's the perception. What meteorological mechanisms, and I think you spoke to this, drive the transport of this dust across the Atlantic to Trinidad and Tobago? And how does it affect our air quality, visibility, and even local rainfall?
Well, with everything that has been going on over the past few years over the globe, the mechanisms and the different meteorological mechanisms across the earth have been becoming, because of climate change, they have a tendency at times to become stronger. So if we have stronger surface events taking place over the African surface for the Sahara, then of course more and more dust would be able to be launched into the atmosphere. And not only more dust, the size of the particles, because of the energy of the wind fields that is pushing it in here, they would be able to be sustained in the atmosphere for longer. And if that African easterly jet becomes stronger, it means then it would be able to push more, a greater amount of thick dust further across the Atlantic. And there would be even less settling velocity or settling directions as it come across. So we in the Western area would be receiving more and more dust because there are stronger mechanisms pushing them across us. And of course, the greater the dust, the greater the effects on us. And then we would start to see even normal people developing respiratory ailments because we are not accustomed to that concentration like this.
Excellent indeed. And well, we'd just like to say hello to a couple of persons who have said hello. We have Andrew, Carlton, Paula, and Lady Rez. So appreciate the greetings. So we have to continue with the presentation, and I think you're going to take us through rough seas and long period swells, and then we'll come back to the participant questions. So back to you, Gary.
Okay, as you say, we have a lot to get through. So I try at this time to give as much information as possible and to have people to ask questions and clear up any things. So one of the things we experience is rough seas and long period swells. And the mid-Atlantic high pressure cell, dependent on its strength and position or shape, is the driver for equatorial tropical Atlantic synoptic wind direction and strength. I put up two surface analysis here. We see one where the high pressure cell is mostly circular or oval, and we see another one where it is stronger, but its shape is different. We're looking at this fetch or the strength of the wind coming outside of the high pressure cell on the equatorial side, and the stronger it is, the more it would affect the sea surface, greater friction, and it would generate sharper and taller wind waves and potential hazards to mariners and boats in open water. That is one part of the effects of the sea itself and the wind speed and friction over the sea surface. But there are also mid-latitude cyclones born mostly off of frontal systems that generate long period swells and traveling great distance, eventually forcefully crashing into exposed coastal areas. And therefore the hazardous seas, the seas would be very dangerous for people operating onshore and near shore. And it could be very strong. You see, if someone was to throw a pebble in the water and we see those rippling effects going outward, that is the sort of effects that long period swells have. And they travel for thousands of miles innocuously across the waters until the energies reach the shallower shores. And we see this great Basha wind ashore. Most of us might have experienced it in Maracas Bay and the northern exposed shores of Trinidad and Tobago. It could be very dangerous, and it could damage structures to the near shore. This is just a picture of showing the type of waves we have. This is close to shore, but it could be like that in open water sometimes. Yes, so the first picture is breaking on the shore, and the second picture a little more open, but we still see the effects of the waves coming on shore. It could be very dangerous, and we usually advise people to be very cautious. We could have yellow levels or orange levels, if you may, for the sea conditions in these cases. So that is one of the effects of us. Now, a very important part of our systems is the thunderstorms. The thunderstorms are the building blocks of the ITCC, tropical waves and tropical cyclones. Each one of these things that you have are made up of a number of thunderstorms, each one of the larger scale systems. So thunderstorms can occur individually at any time, day or night, in any season, when the atmospheric conditions are right. And these microscale with respect to the Earth's surface, or with respect to the synoptic scales, microscale developments might not trigger a cap alert, but can still be very impactful to persons and properties in smaller areas. Thunderstorms starting ingredients are moisture, preferably in the lower to mid levels of the atmosphere. Instability, that is, the air is not stable, really. The ability for the air to change direction with the slightest of push or impetus, and it could go up, it could go down, but the atmosphere has to be somewhat unstable. And warm, moist air is unstable air. And lift, like heating could cause the air to lift. We could have orographic or effects, fountain effects. So we have an agent to lift in moist, unstable air, and this starts the thunderstorm. And the thunderstorm leads times could be possibly as low as 10 minutes, and the life cycle of the thunderstorm approximately 45 minutes to an hour. So we usually have very little time to react whenever there's thunderstorm development taking place. What we need to know is if the atmosphere is in such a condition that thunderstorms are likely to occur. And this is a picture of a thunderstorm. It is in an elevated position, and we could see the thunderstorm is not really, it doesn't really have a proper anvil in this one as yet, but one in the far distance behind here, you can see it has an anvil, and these are some of the more layer type clouds to the mid-level of the thunderstorm. So you can see the size of an individual thunderstorm by itself. Imagine when that happens in a system with other thunderstorms. This one was taken from Piaco. And this is the anvil area here. Below is the cumulus clouds. So you see the size of it to a cumulus cloud. And down here is torrential rain. So I would suspect these areas below here, there will be some sort of flooding effects. And out here, people will be having sunshine. So the meteorologists might predict a thunderstorm over western areas. And some people in some western areas might be saying we're wrong, while the others might be being flooded away. So whenever you see those things happening, be a tone for the persons who have been affected by the weather. So some local effects and impacts of individual thunderstorms. As again, if you imagine cumulative effects, when they occur in clusters or large scales, system or cyclones, we didn't call them thunderstorms for no reason. They're in fact very miniature storms in their own right. We have heavy showers, strong downdrafts, lightning, thunder, funnel clouds, water spouts, tornadoes. Impacts are floodings, flash threat, possibly riverine if it continues for extended periods. We have wind damage, electrical discharge damage, landslips or landslides. Possibly nearly as much damage as a synoptic scale storm or weather event, but occurring in a much smaller scale. So a thunderstorm over your village is as if it's a very small scale actual storm occurring, because you have the wind, you have the rain, and you could get the flooding. So people have lost livestock, pets, furniture and appliances, lives, and livelihood sometimes. And as I said, it might not trigger a common alerting protocol because of the scale of it, but it can still be devastating to individuals in small areas. So what the advice is that you take any forecast with the possibility of a thunderstorm development, take that seriously. And again, you can have a read of the Polari effect from the Varisian guide on page 44. So take thunderstorms warnings very seriously, even if you see the sunshine or the sunlight, because thunderstorms could develop very suddenly. And within the thunderstorms, we have water spouts. This is a picture of a water spout in Manzanilla on Sunday, the 14th of September last year. You see water spout. Water spout is in fact a funnel cloud that has touched down over the sea. And we call it a water spout. When it touched down over land, it's called a tornado. This is a picture taken from the West Moorings funnel cloud into tornado. I think that was last year. And we see the debris being spun into the air by the photograph. And this is some of the effects of tornadoes. And our tornadoes are relatively weak to those that you have in like North America, in Tornado Alley. But you see the kind of damage it could spread upon us as far as the tornadoes are concerned. That water spout went from the sea, and as it hit the warmer land, it sort of developed a little more strength and to that type of damage you see in the photograph here. We also have the effects of flooding. The 2018 flooding in Kelly Village and parts of Trinidad and Tobago and Greenfield was very devastating. It was not really any structured event, but it was coming together of a number of different events, which is too much to discuss right here now. But what it is basically a gathering and a number of thunderstorms because of the setup of the atmosphere that drenched Trinidad caused devastating flooding. We see the level of the flooding and people being rescued here. We see this is a picture of this is the same day picture of the Uriah Butler Highway and the type of flooding we had. If you look to the top left, you'll see blood brown areas is flooding. So we know, those who remember, know the Greenville and the Kelly Village flooding at that time. So we come to our favorite, the ITCC. Everyone should have heard of the ITCC. And the ITCC is a global band around the Earth, generally close to the equator. It moves north and south with the apparent seasonal movement of the sun. I say apparent because the sun don't really move, but because of the tilt of the Earth and the rotation and the revolving, and the different times of the year, we get that notion or that idea or that feeling that the sun is moving, but it's really where the sunlight hits according to the tilt of the Earth. So this ITCC, the convergent band, is around the globe, close to the equator, and seasonally changes north to south. We look here and we see a satellite picture from April 23rd, 2025, just at the end of the dry season that time. We see the ITCC is far south. Trinidad is up to the central left-hand side. The band of ITCC is far south, even south of the Guyanas or into Brazil area. And we see in another picture, and this is, the first picture was coming to the end of dry season around April, and this picture is more the height of the wet season around in August in 2024. And we see the band of ITCC just passing, just around Trinidad and to the north of Trinidad. So if you look at the two variations, the convergent bands could vary very, very greatly depending on the time of the year. And the ITCC is what gives us most of our rainfall, or what usually gives us most of our rainfall in a normal year. And it is made up of a number of thunderstorm activity, as I said. All these systems are made up of individual thunderstorms. You see some development here, some development here. So what goes up must come down. So the areas where we are building thunderstorms, we have sinking areas. Okay? So remember that the thunderstorm is always the building block for these convective systems. And we come to tropical waves, which can be the seeds for cyclone development. Tropical waves at a glance are batches of energy and general spin in the atmosphere that spread from across the Atlantic. And remember I spoke about how the Saharan dust gets lifted and transported across. It is the same mechanism that causes the African easterly jet and the contrast between temperatures between the deep hot air over the Sahara and the cooler, more humid air south of the Sahel, the forested areas, Central Africa and Gulf of Guinea. And this contrast increases during the Northern Hemisphere summer months as the Sahara Desert heats up. And we spoke about that with the same Saharan dust. Well, it's the same mechanism that causes the African easterly jet to send pulses of tropical waves across the Atlantic. And that we see, as I explained, the hotter Sahara or the more humid southern areas south of the Sahara pushing tropical waves across. This is just an example of how a jet would form, and this is not the African easterly jet, but as the air tumbles over the higher air mass into the shorter air mass, it tends to move from high to low air mass, and of course the Coriolis force would push it to the right. Now, if you're going from north to south, to the right of that would mean from west to east. But when you're dealing with the African easterly jet, the right, when the air moves from north to south, and therefore the Coriolis force pushing it right would move from east to west, and therefore towards the Atlantic and across the Atlantic. And that those pulses are the tropical waves that comes across the Atlantic towards us. This is just a mock-up. Things doesn't happen exactly as this is, but it starts off as tropical waves. It gets stronger and stronger, and then you start to have the circulations taking place until you could have cyclonic development. This is just a graphic showing you, and it's not the exact way how things happen, but it's just a graphic showing you the progression. As I said, the tropical waves can be the seeds for North Atlantic tropical cyclone development. They travel across the Atlantic guided by the North Atlantic Bermuda Azores high, or the subtropical high, along the equator side, and moving from east to west, approximately 60 to 65 per year. They peak in frequency around July, August, of course, when the temperature difference is greatest, and therefore the African easterly jet is strongest. And this time of the year, more tropical waves come off the African continent, approximately again about 10 per month. And this is showing the path they take across the equator side of the Bermuda Azores high as they come across the Atlantic towards the Caribbean, one thing that will north, or sometimes they continue into the Caribbean Sea. This is a picture, a satellite picture showing the cloud formations, and I've picked out 3 tropical waves. I can't remember what year this satellite picture is from, but I've picked out 3 tropical waves in the Atlantic. And notice, even as the tropical waves are coming across the Atlantic, just to the latitude or just south of Trinidad and Tobago, notice in the top right-hand corner, we also see in Saharan dust in this area here. So the two things, same mechanisms, two things can happen together at times. And some people say the dust goes away when the rain falls. The dust never really goes away. It is there. We also see some dust here just before the waves approach. We see the shape of the waves in a formation that the meteorologists would pick out together with other observing techniques and technologies. We could be able to pick out the axis of the waves, but a tropical wave is not just the axis alone. And the axis, while most people draw it north to south, the axis can be slanted anyhow you like. This tropical wave here seems to be showing a lot more turning force, what I call vorticity, because of the formation of the cloud. But of course, you have to investigate them a little more deeply. And this is another tropical wave here. So they have different shapes, they have different lengths, wave amplitudes. And because of that, we could have an approaching tropical wave that would affect Trinidad and Tobago at the front of the wave here, might pass Trinidad and Tobago as well as it might go over Trinidad and Tobago. And the trailing convergence most of the time is what would affect us. So when people say you see a tropical wave, the differences and the extent of the weather could be anything, could vary anyhow. So, and the wave is a synoptic wave, so it may not be only for Trinidad and Tobago. So you have this wave, the arc of it could go right over Trinidad and Tobago. And for a day or two, Trinidad and Tobago have nothing to talk about while the tropical wave is passing. And then while the axis is passing, and as it passes, now you see the amount of trailing weather coming across. So there are great variations in the weather that the meteorologist has to be at pains to point out to the general population, because to talk about meteorology and the science of the atmosphere in layman terms is not an easy thing. And sometimes you bring it down to layman terms and you actually lose the science of it. And you may not be saying the correct things in a need to want to talk in simpler language. So sometimes we have to mix the jargon with the layman terms in order to get people to understand. But you see, what we must understand, first of all, is not so much whether it's a tropical wave, whether it's a feeder band or what, but we must understand the impacts of any particular phenomena, because the impacts for each phenomenon vary greatly. So you want to know what is going to happen with each tropical wave, with each feeder band, with each deep thunderstorm development, with each ITCC and things like that. So you, as a layperson, must be more concerned with what is going to happen. Can I leave? Do I have to leave my car at home? Can I drive? It's going to be flooded. Do I have a place to stay if I cannot go home? These are the things that impact-based forecasting must talk about, and not so much trying to teach the science itself, because it takes a few years to be able to get competent in the understanding of the science. But what is immediate and most important is to understand the impacts it will have on people. And we come to tropical cyclones. So tropical cyclones, and this is a picture of a hurricane. They are non-frontal cyclones, which is turning counterclockwise in the northern hemisphere. They are of synoptic scale, developing over tropical and subtropical waters, and having a definite organized surface circulation, which include depressions, storms, and hurricanes. We also have potential tropical cyclone. It is a disturbance that is not yet a cyclone, but it poses a threat of bringing tropical storm conditions or hurricane conditions to areas. And we can now issue advisories up to 72 hours in advance for potential tropical cyclones. That is so as we don't get caught out in the rain, so to speak. Tropical Atlantic, the sea surface temperature must be higher than 37 degrees Celsius. Also, we want warm, moist waters, just like the individual thunderstorms. We want to have the presence of the Coriolis force enough to create cyclonic turning, so it cannot be too close to the equator. Small variation in wind speed and the vertical, that is low wind shear. We also should have a pre-existing disturbance, like a weak low pressure area, no level cyclonic turning, or a cluster of thunderstorm activity, again, thunderstorms, or a tropical wave that has become very sharp and strengthening. And we must also have upper level divergence above the system. Much like a straw, we want the atmosphere wants to draw. The more it draws from on top, the lower the pressure gets below, and the stronger it gets. So the pressure gradient, the geostrophic wind, between the two pressure gradients, or the two pressure levels, from high to low, the wind wants to go there. But the Coriolis force keeps turning it to the right. And there comes a point in time when there's a balance between the Coriolis force and the pressure gradient force. And that is called the geostrophic wind. The stronger that wind gets, friction comes further into play, and therefore retards the wind and pushes it inwards in a counterclockwise direction towards the center of the loop. And where we have a little area here, and as the air develops, or the thunderstorms develop, we find the low pressure getting lower and lower, because more and more air is being sucked out from the surface because of the convective development in the atmosphere. So it gets lower and lower, and the temperature drops greatly within a short horizontal distance, and therefore the cyclone strengthens and blow further and further towards the center and stronger. These are some of the areas. The hurricane season is from June to November. Some areas call them typhoons, some of them just call them cyclones. We designate them from depressions to hurricanes. And in this area here is where our hurricanes are formed, in the North Atlantic area. In our Atlantic basin, we have an area of interest, and the average is for 4 named storms and 1 hurricane over the climatological period. What the climatologists would look at is the El Nino position. As we explained, the different conditions will either support or hinder cyclonic development. The sea surface temperatures, we look at that to see how warm they are. And we also look at what is called the Atlantic meridional flow, that is the temperature gradient between the North Atlantic, the North Equatorial Atlantic, and the South Atlantic oceans in the tropical Atlantic areas. So these 3 factors that help the climatologists to try to predict what type of hurricane season we have with respect to what is normal. And we see this prediction this year, the most likely number of storms, they predicted a forecast of 3, The average would have been 4, so we predicted 1 less. And we have to predict in a range because it's not exact. So we say we're looking at about 2 to 5 storm development within our area of interest. And most likely number of hurricanes is 1, which is the average is also 1 likely number of hurricanes with a range of either none or up to 2. And when we look at on the right-hand side, the tropical storm forecast, we can't make out the figures, the percentages, but the browns and the brown, if you call it brown, and the gray area is mainly normal and above normal and below normal. So we're looking at mostly of the percentages to be normal or below normal as far as the prediction for the amount of storm development. And for most of the pie chart we see here is for hurricanes, we're looking at it to be mostly below normal or the normal. So we see the greatest probability is either normal or to be below normal. So we predicted 1 less storm than normal, but you have heard this saying over the years, it takes only 1 to devastate an island. This is a chart showing the amount of hurricanes and storms over a 100-year period. And we see the peak is usually September the 10th that day. That is a statistic. And the hurricane season peaks between August, the middle of August, to the middle of October, where we usually have most of the cyclonic development taking place in our area. Then we here talk about what is an invest. An invest is simply an investigation of a disturbance in the region 4 that the hurricane hunters would go in and look at it because it is showing promise. And if it is developing, they would look at it to see if it will develop further or to diminish. And the numbers of the invest, L is for Atlantic, so you'd see invest L90 through to 99. And that is just like how we name tropical cyclones, such as storms and hurricanes. We name the invest or we give them a designation. So people will be aware in communication what particular system they're talking about. It does not correspond to how likely a system may develop into a cyclone. It just means that this is the designation for this area we are investigating, and the reports will show whether it will develop or diminish. All right. So we have different stages of developments, less than 38 miles per hour or equal to 38 miles per hour. We have tropical depressions. Between 39 and 73 miles per hour, we have a tropical storm, and it would then be given that name. And from 74 miles per hour and above, it would be called a hurricane. And then you have on the hurricane scale, the Saffir-Simpson scale. There are different categories of hurricanes, 1 to 5. So we have taken out the storm surge and we just talk about the Saffir-Simpson hurricane with scale. And to make it short, the category 1 is a minimal hurricane. Category 2 is a moderate hurricane. Category 3, extensive. 4, extreme, and 5, catastrophic. And some people may ask, why don't we have a 6? But if we're looking at the possible destruction to take place, the scale is saying that once we reach a 5, the destruction is almost complete. So we don't need to put on the not saying anything extra. Category 5 hurricane destroy large numbers of trees and go destroy. So we say category tropical storm, hurricane, and potential cyclone watch and warning, and the watch is an announcement to say that the associated conditions of the system pose a possible threat for a specific area within 48 hours. And a warning is saying that the possible threat has increased, and the specific is likely within the specific area in 36 hours or less. So the warning is a more severe of more severe concern. And we see the IR satellite picture of Beryl. And people say, I've heard recently people say, we are south of the hurricane belt. We are not. If you look at the tropical storm belt, if you look at the information from past years, you will see a number of storms past Trinidad and Tobago. Remember Alma, Brett. In 2017, we had Brett and Dawn. And well, this is one that passed very close, which was Beryl. And together with the cap, we see the Miami warnings and watches here. And for Tobago and North Trinidad, or just at the edge of Trinidad, we had hurricane warnings and we had tropical storm warnings for Trinidad and just north of the hurricane area there. So we, even if we had the hurricane watches and warning, and we are within the hurricane belt, and it could happen any time, especially with climate change and the warming. So we have to be more prepared. But when we were using these watches and warning, we were also using it in conjunction with the common alerting protocol for the possible impacts. And the potential impacts of Trinidad and Tobago is various extents of flooding, street flash, coastal and riverine. We have landslips, landslides, land erosion, strong wind, structure destruction, lightning discharges, potential fires, dangerous electrical shocks, rough seas, swells, storm surge, and we may not have as much evidence of storm surge in certain parts, but it does raise the sea a bit. And we have loss of lives and livelihood and property. What to do when these things are about to happen? But we take heed and we prepare early, because in the middle of a hurricane, it's no time to be preparing. So we long before any weather events, as I talk about the scales, the climatological scale, we would know when it's rainy season or wet season. And you have to understand your area for possible weather events. So you stock up on non-perishable food items, lanterns, lighters, water, grab-and-go bags, medication, some cash, secure important documents, change of clothing, blanket, etc. You also prepare your property if you're in places that usually flood. You get your sandbags before there is even an impending weather event. Clean your gutters, canals, clean your property generally. And one important thing, you know the phone numbers and of your disaster management units and where the shelters are. You also have to keep abreast of weather forecasts, reports, alerts or warning out of Trinidad and Tobago Met Service, the ODPM, TEMA, and one of the major alerts we have is from the National Climate Outlook Forum. We have it every year seasonally, twice a year, before the rainy season and before the dry season. So you have to know what is going on. You sign up for the Trinidad and Tobago Met Office app to get information on your phone, and there's a ODPM public alert system that depends. You could sign up for that also. So you have to keep abreast of what is going on. Even if you're getting different reports from different areas, you have to keep abreast of what is being said by the official bodies of ODPM and the direction of ODPM and the Trinidad and Tobago Met Service. And of course, we know the country we live in, we know the type of weather we get in where we live. So we should be far ahead, advance of the game, and not even waiting until a yellow level or orange level or red level is put up. And this is just some idea of an emergency go bag. It is simply a bag with first aid in bits, tactical flashlight, a whistle, multi-tools, sleeping bags, water, food packets, and a compact sleeping bags and different things to keep you as comfortable and alive as much as possible during these times. And you may have to grab your bag and go to a shelter. Radios that are battery radios or wind-up radios. Change of clothing, of course. You have to get medication, medical supplies now in advance for at least a week for people who need it, because you know the pharmacies might close down and may not open back up because according to the strength of the devastation, and some people may need medical supplies. So take the supplies and start, not too much for them to spoil, but enough that you could use it and replenish long before anything happens. And Robbie, anybody have questions?
Yeah, so again, this is really thus far a masterclass. I think a lot of information. I see we have a couple of questions coming in and we could probably take them. And just a reminder to all participants that you can ask questions either via the YouTube chat. You can also send either an SMS text message or a WhatsApp to the number 74REACT. Okay, so again, 74REACT, which is 747-3228. Again, 747-3228. WhatsApp or SMS text your question. So we have a few people saying hello. Ronald saying hello. Also Rohan and Basil. Thanks for joining us. Really appreciate having you. And we have a question. You mentioned the Sahel region, and I see we have a question coming in from Eric that asks, he says, hi, how will the proposed Great Green Wall project affect Sahara dust propagation into Trinidad and Tobago and the Eastern Caribbean, if at all? I suppose he's referring to that initiative that they started to plant trees, I suppose, in the African region. So the question again, how will the proposed Great Green Wall project affect Sahara dust propagation into Trinidad and Tobago and the Eastern Caribbean, if at all? And then we'll get to the other question I see here. Over to you, Gary.
Oh, all right. I am not too familiar with the Great Green Wall project, but if it means reforestation and planting trees in any area, it means that the soil would now be covered in certain areas by trees and therefore less dust to be projected into the atmosphere. Now, the Sahara is a very large area. One of the earlier pictures I showed you with the tropical waves, we see while the wet tropical waves are coming across the moisture area, I was showing to the top right-hand corner, we were seeing that the Saharan dust was even heading towards the northwest, not coming towards the Caribbean, but the Saharan dust would be coming across. As long as there is dust on the Saharan surface, there will be mechanisms which would lift it. Even in Trinidad and Tobago in Port of Spain, as long as dust in the ground, you'll see a wind pickup and everybody have to mostly cover their eyes because dust will come into your eyes. That is what is happening across the Sahara in a larger scale. So yes, if you have trees being planted and reforestation, it would have that much more moisture around the Sahel area. And there was some, I read that some years ago, that it was found, or they believe, that if the Sahel area was more moist, more lush the year before, then there's a tendency to have less Saharan dust, because dust, when you're dry and you want to stop the dust from blowing up, you tend to sprinkle the dust with water. So any moisture content around the Sahel, increased moisture, it was found, I don't know how, I can't get into the details of it, but it was found that there's probably the tendency for less Saharan dust because the dust just around that area would be a little more moist and just more difficult to be dislodged into the atmosphere. But as long as there's a large area of dust and these mechanisms starting to take place to blow the dust into the air, you're going to have the dust coming across. So there's a balance between the, and of course the people, the experts involved would have to see how much they could do, and therefore other people, the people who know more about it would wait in time to see how it works. But yes, I'm saying that once there's reforestation, there's a tendency for less and of course the surface will be covered more in moisture trees and less dust is able to be dislodged into the atmosphere.
Okay, excellent indeed. So again, questions either via the YouTube chat or via WhatsApp or SMS text to 74REACT, which is 747-3228. Again, text your questions or WhatsApp your questions to 747-3228. So we have a couple more questions to deal with, Gary. So Carlton is asking, because of technology, we can now monitor the Sahara dust, but how long has it been affecting us?
A lot of the systems on the Earth's surface has been affecting us for as long as we had an atmosphere. We have had paleoclimatological changes in temperature. We have had cooling and warming periods. We know this. But what tends to happen, because we have greater and greater technology that could drill down and be more granular in observing the Earth's atmosphere, we now could tell to a greater extent what is happening. So it sort of is a psychological thing sometimes. Some things have been increasing in intensities because of the climate change. The temperature, of course, we know we're in a warming period. But because we're now able, before a few years ago, only the meteorologists would have been able to see satellite pictures and things like that. And therefore, people would have been more dependent on what the meteorologists say. And now, because we have all these technologies, satellite pictures on your phone, everybody could watch the satellite picture. And some people tend to become meteorologists as a result of that, and therefore give their opinion. But the understanding of the atmosphere becomes greater and greater for the meteorologists as far as being able to predict what is going on. So yes, it appears like some of these things are now happening. No, some of them have been there for the longest while, and we are only now observing them, or even discovering some of them, or even discovering the extent to which it works, and even coming up with names for them that we never had a name for or didn't know what it was before. So now we're in a greater time with more and more technology, and therefore, while we have the right to information, we have a greater onus of responsibility with what we do with that information.
Okay, excellent indeed, and certainly great questions. So we have one more, perhaps, before we continue. Wazim asks, what is the current state of the Doppler weather radar in Brazo Venado?
I have no real details on the state of the radar, and for me to give you an answer on that right now, I will be talking out of turn, because I have not consulted with the technicians who deal with the radar at any point in time. So I would not want to make any statements on that radar.
Yeah, and that's fair enough. So let's, well, we know we have France versus England at 5, and I guess we can continue with your presentation there, Gary. Take us into the Common Alerting Protocol, or what we say as CAP. Over to you.
All right. Remember earlier I spoke about watches and warning for the cyclones, and I went into an area of Australia where we had the watches and warning according to NHC, and therefore we understand what is likely to happen in a future time as far as the progression of tropical cyclones are concerned. But we also have a common alerting protocol, and it is impact-based in the sense that we are looking to see the type of weather that would affect us. Yes, we know there's an approaching tropical wave, there's an approaching tropical storm, or whatever have you. But we want to know what is the type of weather, because just saying a tropical wave is approaching, it doesn't give us for any particular area what type of weather any one person might want to might be affected by. So we look at the impact on the matrix, whether the impact is going to be very high or it's going to be low, and we look at the likelihood of it occurring within time. And most of the things would fall within the green area, which is normally impact would be low. Even if it is very likely, the impacts remain low. But when the likelihood of the impacts begin to increase, we could get into the yellow area. And then as it increases further, it is a balance between the very likelihood of something occurring, of an event occurring, and the impacts. And therefore, it would place it either in the yellow, orange, or red. And God forbid, we don't want to go into the red. But it would place it in any one of those colors. And therefore, we could give alerts according to the color scheme of the CAP. Because of the scales of time and space within which weather systems develop and weather events can occur, the lead times of predictions and dissemination vary vastly. I think I mentioned that earlier on in the scales. Weather systems of different scales interact with each other and influence their effects. There is, for instance, tornado development within thunderstorms or cyclones. Therefore, for every individual color code, alert, or warning, there would be necessarily be different reasoning and lead times for dissemination. A major drawback could be for the CAP system is the misunderstanding or belief that every CAP, alert, or warning of the same color comprises of the same information or the same details, and therefore persons might have the same response expectations every time, and this is not the case, especially in the case of the yellow level, which we have more. For every CAP that is sent out, there is different information. They may be very close, but there's different information as to the type of impacts and even what you should do in that case. So consideration has to be given to not just the hydrometeorological phenomena, whether it's a thunderstorm, a tropical wave, or what have you. But we have to decide with a certainty, what certainty the weather events is likely to occur, or if it is occurring as a result of the phenomenon. What are the expected or ongoing impacts of the weather events? The impacts will vary according to the intensity of the event and time and space which it covers. Flooding is one which varies very, very vastly over time and in different places. We could start off with just street or flash flooding, and it could quickly go into localized flooding. And then as time spaces, we could see the rivers coming up and it could go into riverine flooding. So we have to be understanding all these things. And every upgrade, every number of CAP we put out, we must necessarily try to understand, well, what is this CAP saying? What is the events? Is it lessening? Is it increasing? What must I do for the impacts? And this is a picture of a CAP that gives you a time of date and issuance time, what the event is, what is the message type, adverse weather alert number 2, yellow level, the area of description, the start and end time, the urgency, the severity, the response, what you must do, what certainty is it observed, is it independent, and then we have a description in plain language would tell you that this one says, due to a combination of ITCC and a low-level trough and all these sort of things, and there's a 70% chance, and rainfall might be in excess of 25 millimeters. So you have all these things happening in a CAP besides the matrix. So it is very important when a CAP is released that you try to understand what exactly is this. Even though it's a yellow level CAP, what exactly it is saying. In the first instance, it might be a weather alert. It may be a high wind alert. So you have to understand, is this a yellow level for high wind for you? And that part is always obvious. But for the description, you must take the time to understand what this CAP is describing and what you have to do, what you're required to do, or what you're advised to do in the case of this command alert protocol. And we have, you would also get a touch area where it is likely to happen. With the riverine flooding, you may see it across the rivers, river basins. With the high or rough seas, you may see the lines across the exposed north and eastern coast of Trinidad and Tobago. But this one is adverse weather, and it was expected to happen anywhere over Trinidad and Tobago. So the touch is across all areas. Of significance is a green level does not mean that the ongoing weather events have stopped. Green level, that means normal conditions with relative normally in the rainy season. Rain would fall normally. So when we say we discontinue the yellow level, it does not mean that the rain has stopped or the weather events have stopped. It means that the threat, because remember the CAP is an impact-based system, it means that the threat of significant weather impacts associated with the reason for the issuance, that particular alert or warning, it has decreased to an extent whereby the conditions fall within the green levels of the matrix. And more than one CAP could be issued simultaneously for different types of hazards. So you hear people saying, well, look, now that it's stopped the CAP, the rain now So a heavy shower falls over your house. And you say, well, it always happens this way. Every time they stop the cap, the rain begins again. So the famous quote is that they don't know what they're doing. But the fact of the matter is, the green means that the impacts associated with the reason for the issuance of the particular alert, it has decreased to an extent whereby conditions fall within weak levels of the matrix, and therefore it doesn't warrant a yellow level. But that doesn't mean to say if it was for rainfall that you wouldn't get a shower or two still ongoing as the impacts or the system winds down and moves away. So we're coming to the end, so we could prepare some more questions. So the CAP compliant hydrometric system is an international system and adopted in Trinidad and Tobago, mostly to the international standards, two international standards, in fact. So the green level is low risk to public safety, livelihoods, and property. And the risk pose has dropped to a safe level, as I said. And it is used mainly for cancellations or discontinuations. The yellow level is for moderate risk to public safety, livelihoods, and property. Conditions may cause some disruptions in a few places, and there is some potential for harm. Most people will be able to go about their normal activities, but some will be directly impacted. Now, the yellow level is the one that poses the most problems for us because people tend to read it because it is the most issued one. And as I explained just now there, you have to understand what the yellow level is saying. And with the yellow level, things could either go back to green or it could jump to orange very quickly. So you must always understand what the yellow level is saying. It's saying that most areas, most people could go about their business, but it means that you must have a heightened awareness of what is taking place with the weather so that you could go ahead about your business, but do so in a way that you could be able to respond appropriately if there's any changes in the weather. Orange level, when you hear orange level, it means that it's high risk to livelihoods and property. Hazardous conditions threaten lives, livelihood, and property, and serious injuries or casualties are possible. So orange level is a very serious level of the cap, and by then you should be making preparations to protect yourself or hastening to finish your preparations and access the safety of your current location. Even if this says access the safety of your current location, of course you should do that even before the season started or during the season to continuously assess the safety of your location. Of course, when red is a very high or extreme risk, what can I say about the red? It is, you have to be, if you are not in a safe place, you must at least be already evacuated or take immediate action to safeguard your family or to evacuate a safe area. So we don't really use the red just like that. But when we see orange or red, you know, there's serious business. Not that yellow level is not serious business, but yellow level is saying here what we have to, something is happening or something is possible to happen. It may not be happening in your area yet, or it may not happen in your area at all, but there's the possibility that something could happen. So let us perk up our listening ears and try to see what's going on with the weather in case anything happens more serious than already is occurring. And so that with the cap, I came to the end of my presentation. Robbie? So
Indeed,
if there's any questions.
Indeed, Gary, and certainly this has been a masterclass. I think some of us will want to look over this webinar afterwards, and it will be available on YouTube as a recording because quite a lot packed into a short space of time and a lot of details inside of there to pay attention to. So, so in terms of questions, so Gary, Lorenzo is asking, why is it that sometimes when it rains, there is no lightning, but sometimes there is? Okay,
it could be any number of reasons, but the major reason is that the precipitation is falling when there's lightning from convective type clouds. Remember, I spoke about the importance of thunderstorms. That convective type cloud is a thunderstorm. So most times when you're getting lightning is because a thunderstorm is occurring. And when you hear thunder, of course, lightning is a sound, thunder is a sound that lightning makes because it heats up the atmosphere and the atmosphere expands beyond the speed of sound, and it breaks the sound barrier, and therefore you hear the thunder occurring. So when you see lightning, it's because you have that convective type of activity out of the thunderstorms of which I speak. Most times you see in rain with layer type clouds and kind of continuous moderate light and moderate rain happening over long periods of time. It's really rain from stratified types of clouds, and they could cause flooding because of the accumulative effects. In fact, somewhere on the east coast of Trinidad some years ago was washed away, and I had not observed a single thunderstorm in that event. Not that it didn't occur, but the rain itself was so strong that no thunder, but it was having heavy rainfall. So the rain would normally fall from stratified layered type clouds, and the thunder and lightning or the showers we're talking about. Convective activity would fall from cumulonimbus type clouds that would give you the lightning and the thunder.
Okay, excellent indeed. Excellent question and certainly excellent response. Okay, so next question for you, Gary. How do El Nino conditions and Saharan dust outbreaks interact with each other? Does one phenomenon tend to amplify or suppress the effects of the other in our region?
It is difficult to answer the question. I could use, because of my understanding, I could make some, if you like, educated guess about it. But the fact is, when you have El Nino, it affects the weather in all parts of the globe, so that it is possible. Remember, the Saharan dust is launched into the atmosphere by virtue of certain surface events taking place. El Nino will affect the winds around the globe. So it is possible to affect the wind in one way or the other, but for me to say which way it is, I have not studied that. But because of where the El Nino is strong, it is possible to affect different parts of the wind system. And therefore, if for 1 year, for one reason across the Saharan desert, there is less surface phenomena that would launch the dust into the atmosphere, then therefore there would be less dust. If it causes more surface events, then there will be the more dust into the atmosphere. Also, you have to look at the African easterly jet. You have to look at the Bermuda Azores High and how these things are affected by it. But these things are being investigated from time to time. And to say one way or the other, I would not say definitely, but because it is possible because of the effects or the long-reaching effects that the El Nino could have. And remember that the El Nino, we say El Nino because it's just in nature what we're talking about, but there's a whole system of the ENSO, which is the El Niño-Southern Oscillation, which goes from phase to phase at different times. So different things could be affected, whether it is in the La Nina phase, the Drought phase, or the El Nino phase.
Excellent indeed. All right, so we've been going for an hour and a half, and we know we have France v England coming up, and tomorrow Argentina, Spain. So let's look to put a wrap on today's session. I mean, I think I'll keep using the term masterclass. I think there's been so much information presented and compacted into a short space. Very understandable information. Great questions from the participants. And, we will do it again. I mean, Gary, this has not been the first time we have had you on a webinar. And at all occasions, you have really generously given us a lot of information, a lot of food for thought. So, this evening certainly has been an engaging and interesting presentation on the topic of the effects of El Nino and Saharan dust on Trinidad and Tobago. In bringing today's event to a close, we would like to thank Camille Hall Graham, Corporate Communications Officer of the Trinidad and Tobago Meteorological Service, Dennis Marcel, Operations Manager and Captain, retired Stefan Afonso, Deputy CEO of the Office of Disaster Preparedness and Management, that's ODPM, Alan Stewart, Director of the Tobago Emergency Management Agency, TEMA, Bert Williams, Technical Director, and Charmin Williams, General Manager of HeartlightTV, the streaming provider for today, and all support staff of these organizations for their partnership. A special thanks goes to the presenter for this evening, a legend in his own right, Mr. Gary Benjamin, senior meteorologist, without whom today's event would not have been possible. Thanks to all attendees who were part of the live audience and those who fielded questions for spending the afternoon with us as we really do this for you. The recording should be available via the same link, so for looking over any aspect for persons who may not have been able to attend the live stream. I'd like to say thanks to the chairman and board of directors of REACT International, the presidents and teams of REACT Trinidad and Tobago Council, REACT members and their families, fellow communicators, colleagues in the amateur radio fraternity, the Zello communications partners and CB radio operators, the Trini group members, and the weather community in general for their support and various contributions towards making this event possible. Look out for other sessions in the future. To get in touch with REACT, please call or text or WhatsApp 1-868-74-REACT or email us at info@ttreact.com. Check us out on our social media platforms and consider interacting with us via the public Zello channel REACT members. So Zello is a free walkie-talkie app. For persons interested in becoming a licensed amateur radio operator, we have free online training courses for the American exams, which can also be used to obtain a Trinidad and Tobago ham license. As a matter of fact, a new level 1 cohort will be starting in September of this year. So contact us, again, the number 74-REACT via WhatsApp. So thank you. Wishing that each and every one and their families continue to be safe. Do enjoy the rest of your day. Bye, everyone.